Wilkinson. I'm one of the authors of Springboard Science, and I'm just going to briefly show you how I use the Springboard resources with my classes, and you can see that in my room I've got set up with a projector and the PowerPoint slides onto an old smartboard, which I don't use as a smartboard anymore, like many people, and I've got a whiteboard as well, and I've got myself a visualizer and camera. I'm going to show you how I use this today to teach my Year 9 class about the rock cycle and how sedimentary rocks are formed. Now, the first thing you'll notice, if you've already got the PowerPoint slides, is that this is not the same slide, the same general science quiz that you find on your PowerPoint. And the reason for this is that my class yesterday had already done how igneous rocks and metamorphic rocks had been formed. I taught them that, and then we did the independent practice questions on that, and we haven't got through the whole of this topic, and that's going to be quite a common thing. Some of the topics are very, very large, and they shouldn't be seen as individual lessons. You should see them as a topic which fits together in terms of a unit of a thing to learn, but it's not necessarily the length of one lesson. And so sometimes you might have to write a new general science quiz that your class will do when they come in at the start of the lesson. And so I wrote this new science quiz, which is basically based on what the class did yesterday on how igneous and metamorphic rocks are formed. And then you can see that I went through the answers to this quiz on my whiteboard. However, it's not so important that I check the understanding of every single question, every single student for these questions, because it's not entirely necessary for the things that they need to know for today's lesson. Then I did a prerequisite knowledge check of the things that they needed to know in order to understand sedimentary rock formation, which was mostly about understanding weathering from their geography lessons. And then I got on with my explanation of how sedimentary rocks were formed. In the PowerPoint, there's visual cues that sedimentary rocks are formed using rivers, and there's this sediment in a river delta picture. And there's two examples of sedimentary rocks on the border of limestone and sandstone. And in fact, I used samples of limestone and sandstone after my explanation in this lesson, so that students were able to feel some of the properties, the crumbliness of the rocks, for example, after my explanation of how sedimentary rocks are formed. The next slide is a completely blank slide. What are sedimentary rocks? And this is where you introduce your explanation, your guided explanation of how sedimentary rocks are formed. I use my visualizer to do this. And so I use my camera, and I zoom in so it's nice and big and nice and clear for all the students to see. And then I draw my picture and my guided explanation of how sedimentary rocks are formed. And so that explanation goes something like this. Basically, I'm not a great artist, but it doesn't really matter. So I talk about the fact that sometimes rocks might end up at the top of a mountain, and when they're at the top of the mountain, they get rained on quite a lot. And this rain, and also the wind and rain, cause little bits of the rock to fall off. And we call this process weathering, and these small bits of rock, we call them sediment. And that is small bits of rock. And these fall off the rock in a process called weathering, which is caused by wind and by rain, but also by plants and all sorts of other weathering processes, sometimes biological, sometimes physical weathering. And these bits of rock get carried down the mountain by the water. Okay, so the sediment is carried by water down the mountain, by rivers, and sometimes this can even happen underground through underground water systems, depending on whether the hill that the rocks are on is porous and whether water is able to pass through it or not. But this sediment makes its way carried by water to the sea, and then once it gets to the sea, it starts to form, the sediment starts to layer up in the bottom of the ocean. So the sediment gets there, and then the sediment sinks to the bottom, and as it sinks to the bottom, they get layers of sediment in the bottom of the ocean. And so there are layers of sediment in bodies of water, such as lakes or oceans. And these layers build up over time, and as they build up and build up and build up, then the layers at the bottom are getting squashed and squished together. And this process can take millions of years, but eventually these more and more layers are deposited at the bottom, and they're squished and compressed under the weight, and over millions of years, what's formed at the bottom here are sedimentary rocks. And so this was my explanation to my students as to how sedimentary rocks are formed, and I then go back to my PowerPoint and show them a couple more examples of sedimentary rock. And I say to students that because if dead animals get trapped in those layers of sediment, then they can sometimes form fossils. And here's 2 examples of fossils. So an animal has died and it's got trapped in between the sediment, and then it's squished together. And as the sedimentary rock is forming, then we get this kind of outline of a dead animal inside the rock. And so that's how fossils are formed. Here's 2 examples of fossils. And then I show students another example of a sedimentary rock. So this is a sedimentary rock called conglomerate, and conglomerate is very much classified because of the nature of its sediments are of different sizes. So some of the lumps of sediment are very big and some of the lumps of sediment are very small, and they've all been squished together over time. At this stage in the lesson, I also got out my samples of sandstone and limestone so that students could experience that mixture, that get to feel what the properties of those rocks are. And then we summarise the properties to go with yesterday's igneous and metamorphic rocks. We talk about a summary table. So sedimentary rocks are formed and carried by water, settled and crushed by layers above them over time. Their identifying features are that they are soft and crumbly, that their grains in them are rounded, they can contain fossils, and that they are porous. So that means that water can travel through them, which is not a property that we get of igneous or metamorphic rocks. So explicitly highlighting to students that porous nature of sedimentary rocks is different to igneous and metamorphic. And the common examples include limestone and sandstone. Once students had done this, I was then able to give students some time to do questions 13 to 17 from practice book 3, and students were given some time to do those questions, and I was able to circulate and check whether they were getting on with that. And then I was able to use the PowerPoint to go through the answers to those questions. So the sedimentary rocks are formed, small particles are deposited at the bottom of lakes and rivers and compressed together over time. Common properties of sedimentary rocks, because but so activity, which gets students to think about fossils and how often fossils are found in sedimentary rocks. So they're found because dead creatures can be trapped in sedimentary layers, but not found in igneous rocks. And so we can use sedimentary rocks to age the fossils, and they can be used to identify sedimentary rocks themselves. Further independent practice, talking about the idea, to consolidate the idea that sedimentary rocks are porous. Here's a little question where students have to work out how much water has been absorbed by the rock. Identifying that this is going to be a sedimentary rock because it's absorbing water, and we would say that it's porous or permeable. Again, some questions about our use of limestone. And then I went on to identify with students what the rock cycle is, how metamorphic, igneous and sedimentary rocks can all be turned into each other, and the processes by which those occur. Again, you'll see this is a blank slide, and I went back to my Visualiser to step by step explain explicitly to students how this works and the processes by which those three types of rock can turn into each other over a process of millions and millions of years. Then out came the mini whiteboards, and the mini whiteboards allowed us to check for understanding and why can't I go up a slide? Go back. There we go. And using this diagram, check for understanding that students understood how the rock cycle occurs and how those different types of rocks. So you can see that this is a diagram similar to the one which I drew underneath the Visualiser, but it's not got all of the labels. It's got type rock A, type rock B, type rock C, and the idea of sediment and molten rocks. And students had to show me using their mini whiteboards that they were able to understand what each of these labeled processes were and what all the types of rocks are that are there. Really, really useful to be able to get information from every single student. They've understood the processes of formation of the three types of rock and how those three types of rock can be turned into one another. And then once that mini whiteboard activity was complete, there was more independent practice questions on the rock cycle. And that basically finished off the lesson. We're going through the answers to those independent practice questions at the end of the lesson. I hope that's been useful for you to understand how the Springboard resources can be used with alongside the PowerPoint and a Visualiser. Just need to switch backwards and forwards between the camera and the PowerPoint to use the Visualiser for the general explanations. I hope that's been useful. I hope you find Springboard useful. Thank you very much for watching. Take care. Bye-bye.